We are going to look at transposition. Transposition is another way of saying rearrange the formula. As you can see here, I've got A, B, and C. These are known as variables. Those are symbols that often represent a number. A plus B equals C. C is known as my original subject. Transposition will look to make either A or B the subject. Let's look at an example. So in this example, I want to make B the subject. To make B the subject, I need to move A across to the other side. There are laws of algebra that I need to follow in order to do that. And those are opposites. So if it's an addition, I'll do the opposite on the other side, a subtract. That's a multiply, I'll divide, and so on. So as this is an addition, I'm looking to subtract. So A, subtract A. I'm going to put that in brackets, so I've got to do it first. Plus B equals C, subtract A. In transposition, what we do to one side, we do to the other. So A, subtract A, cancels itself out. So what I'm left with is B equals C, subtract A. If I was to assign numbers to those letters, it would look like this. Let's say A is 1, B is 2, C is 3. Using transposition, I've got in brackets 1 minus 1 plus 2 equals 3 minus 1. Or they cancel themselves out. I've got 2 equals 3 subtract 1. Let's look at another example. When you're taught Ohm's law, you're taught to use a triangle. The triangle method is easy. All you've got to do is cover the variable you want, and that gives you the equation. So cover V, I times R is the equation. But the problem with using triangles is when you come to more triangles and the variable is in a different position, it becomes complicated. But if we use the transposition method, we don't need to remember multiple triangles. Let's look at an example. In this example, I'm not going to use the power triangle. I'm going to use transposition to work out the formula. So here, I've got voltage equals current times resistance, or V equals I times R. I want to make I the subject. So what I'm going to do is divide by R. What I do to one side, I do to the other. Because I've got two R's, they cancel themselves out. So what I'm left with is I equals V over R. On this example, V equals P over I. Voltage equals power divided by current. I want to make power the subject. So what I'm going to do, because that's divide, I'm going to multiply. What I do to one side, I do to the other. Because they're the same, they cancel themselves out. So what I'm left with is P equals V times I. And that's using transposition instead of the triangles. Let's look at another example. In this example, we've got P equals V squared over R. I want to make V the subject. The first thing I'm going to do, because that's divide, I'm going to times. What I do to one side, I do to the other. Because they're the same, they cancel themselves out. So what I'm left with is V squared equals P times R. Problem I got now is I want to make V the subject. The opposite of the squared is the square root. So V equals the square root of P times R. Let's look at another example. I'm going to look at the transposition of the resistance formula. So here I've got resistance equals rho, the resistivity, times length over the cross-sectional area. I want to make length the subject. To do that, the first thing I'm going to do, because this is divide, I'm going to multiply. What I do to one side, I do to the other. Because they're the same, they cancel themselves out. What I'm left with is R times A is equal to rho times length. I now want to get rid of rho. So, because it's multiply, I'll divide. What I do to one side, I do to the other. Because they're the same, they cancel themselves out. So now the formula is length equals resistance times cross-sectional area over rho, the resistivity. Let's try another example. Let's look at this example. I want to make R the subject. So the first thing I can do, this is a square root. I can move that across and make that squared. Let's get rid of that. The next thing I can do is move this XL squared. Because that's add, I'll then subtract. I do to one side, I do to the other. Because they're the same, they cancel themselves out. What I'm left with, R squared is equal to Z squared minus XL squared. Because that's a square, I can move it across. I can make that into a square root. So now R is the subject.